mapping, member design, result visualization, and finally some words about Revit, SOFiSTiK, and Dynamo. So quite quickly for the first demonstration, I will give the screen and the speech to my colleague Andreas, which will talk and do the first demonstration. Oh, I just have to.
Okay, so thank you, Noélie. So we are just need to make me as moderator, and now you should see my screen right now. Okay, so yeah, Noélie already mentioned, I will start with the first demonstration. What is new about modeling in our SOFiSTiK analysis and design app? So what we are covering today is SOFiSTiK analysis and design for Revit 2021. Yeah, but some of the features, and I think I will mention that later on, will also cover features which are already available for Revit 2020. 2020. So I'm now switching to Revit. You can see now a building, yeah, a typical structural model of a building. This can be a residential building or a office building, and now I will start basically from scratch. So I assume I got this model from an architect, and now I want to do a structure analysis for this system. So first of all, having a look at the SOFiSTiK analysis tab over there. So once you install SOFiSTiK analysis properly, you will see that SOFiSTiK analysis tab showing up in the ribbon tab in parallel to all the other commands of Revit, and this tab gives you access to all all the commands allowing you to perform a structure analysis within Revit. So for example, commands to perform the analysis itself. We have the mapping mechanism is accessible here. Also design commands and utilities. There are especially new in version 2021. There are two commands which can be seen here. One command to display results directly in Revit, so to display analysis results, and another command to publish, so to collect design results and to publish them in different formats like Word or PDF. Yes, as already said, I assume that I got this model from an architect, and I think most of you are familiar with the fact that Revit, when switching now, I'm switching now to a different view, that Revit already provides a structure or an analytical model in parallel to the structural one. So you can see that here in this view displays the physical elements in a transparent view, and in parallel to the physical elements, you already can see that analytical line of this physical element. This is essentially a kind of a property, so I could also switch it off in order to ignore this element, for example, in analysis. Yes, so you will already have that in parallel, but in the general case, and this is our experience when working with customers, in the general case, when you get a model from the architect, this analytical model provided by Revit automatically is usually not clean enough to conduct a proper analysis. So there might be errors or inconsistencies within this model, and this is often relatively tedious and task to clean up the model such that it can do an analysis. And in order to support that process, we are providing an analytical check. An analytical check to check the model prior to analysis. So, and this check has been enhanced with version 2021. So we now distinguish between different classes of checks. So a first check checks the properties of the elements. So whether materials, for example, are appropriate for analysis. We are also checking the geometry. So, for example, it could be that two surfaces overlap, and these kind of issues are being reported when activating this check. And what is also new for version 2021 is that we also check for a kinematic stability. So this means if a member is not connected or is not properly supported, you will encounter kinematic instabilities during analysis. And in order to avoid these issues, you can check that before and search for those situations. So let me shortly highlight this process, an example of this column. So I'm just changing the analytical model of this column manually, and you can imagine that if this shows up, this small issue shows up in a large model, it's not that easy to find that situation using the check. The system is being analyzed in the background, and now a error dialog shows up, indicating that two checks has been failed. So one check indicates that a column member is not supported well, and another one also deals with columns. So it checks whether column standing on top of each other are properly aligned. And now I can select this issue here, and using that show command, it displays the respective element. There's also the possibility to isolate that specific region. And now I can easily solve that issue in this isolated view, for example, and switch back to the general model again. So this is essentially, or probably, the first step which is being done when you get a model from someone else to check for the analytical consistencies using this command. Yeah, and once you did this, you can start adding attributes to the elements. So adding attributes, for adding attributes, we provide a specific structural properties pane, which can be activated here. I already have it active, and this works same way as with the standard Revit properties. When selecting an element, this property of the elements show up, and there you can add additional analytical properties which go beyond the properties already provided by Revit itself. So, for example, you can give the element a group number, you can give it a name, or what is new, you can decide whether the element should be calculated as a standard beam element, so a standard beam element with all 6 degrees of freedom being active, or instead of analyzing it as just a truss element, or you can also analyze it just as a cable element, which can only receive tensioning forces. You can also, which is new, also assign the element a number. So you can give the element a number, the so-called structural element number, in order to identify the element later in the design process within SOFiSTiK. Same for areas, or what is new for version 2021, also that you can also assign groups and a name to boundary conditions. So, for example, especially important is the fact that you can assign groups. This allows you to activate and deactivate a boundary condition during, for example, a staged analysis in SOFiSTiK later on. So, for example, to apply temporary supports in a staged analysis. Yes, and once we added that structure information, we can also add loads. I already did that already, so I'm switching to another view, which displays additional live loads, additional self-weight and live loads. And now I can directly start analyzing the system using this command over there. And this command gives you access to a number of parameters which you can configure before analysis. So there are commands, for example, or options to control how the geometry is being handled. So, for example, there are also geometry cleanup. You can define a tolerance, or you can define that small openings will be ignored during analysis. Also, you can configure the meshing, the mesh size, and other parameters in meshing. And for the analysis, so you can do a quick analysis directly from within Revit. So in this case, I will perform just a linear analysis of all the load cases of Revit, but it's also possible to include load combinations defined in Revit. You will see that later in this webinar. Or you can also account for construction stages defined in Revit. And now I'm just calculating this system. You see in the background now, SOFiSTiK programs are called. So we are creating a final element mesh, and now we are analyzing all the load cases. This takes some time, of course, but now we are finished. And now we can visualize the results, or, which is probably the most common use case then, that you switch to SOFiSTiK Structure Desktop now. So I open this button, SOFiSTiK Structure Desktop. This gives you access, or here, as I'm just opening it the first time, you can select for a template, which you can define before, and this template may then contain your manually defined design tasks. So I'm just selecting this template, and now the SOFiSTiK Structure Desktop opens up. And this is the main environment. So the SOFiSTiK Structure Desktop is the main environment to conduct structure further design and analysis tasks within SOFiSTiK. So main control is being performed through this task tree. So you can add new tasks, you can configure these tasks. So for example, in this case, this default template just provides you with tasks for enveloping and combinations, and for code checks and design of reinforced concrete. But this is the main environment for SOFiSTiK, so where you then will perform all additional tasks. And once you configured your task and you change your model in Revit, you can just batch run through this task, and all the design and all the printouts will be generated instantly within SOFiSTiK Structure Desktop. I will close it again because this goes beyond the scope of this webinar today. Just in short, I just wanted to highlight one point, is the mapping. I haven't covered it when exporting, so but this has been done automatically in the background. So you will see here that in the background, the software analyzed the Revit materials and assigned an appropriate SOFiSTiK material to this Revit material. In this case, a concrete material based on Eurocode. And from here, you can further configure this default assigned material with all the parameters you would like to adjust. Even stress strain curves for the different limit states can be configured here. And you can save that again, and once you change that information, this will be automatically mapped to the Revit material and will be stored in Revit itself. So this is a kind of data which is being stored in Revit. Same is for sections and load natures. Regarding the sections, I will come to that back in the second demonstration today. And all that data is, as said, stored in the Revit database. So this means you can access this information and check out this information also in a new dialog, which can be seen here, where you can access material and cross-section information from here and also configure that. So this new dialog gives you an overview of all the information stored in parallel within the Revit database and information which is required for analysis. Yeah, SOFiSTiK analysis, one major point of SOFiSTiK analysis and design is its ability to control or to manage different kind of analysis systems in parallel to this main system, because it's usually the case that you don't want to do all the detailed analysis based on the results of this global model. Instead, you would rather switch to some subsystem, which I already prepared today. So there are also commands to create that subsystem from the main system. But here I already prepared the subsystem, and which consists of these two slabs of the level 3. And it also displays the supporting members here. And what I would like to show you today is now how you can subdivide the loads according to a defined loading pattern, because this command has also been revised today. So there is not only today, has been revised for version 2021. So this command loading pattern allows you, I just select this area load and these lines which I already prepared. And now when finishing the command and clicking OK, you will see that now loading pattern loads has been generated. I will just switch off the large area load in this view. And you see that pattern loads now has been generated according cut along these lines. And yeah, this command has been revised with version 2021 such that it can now also account for any kind of geometry. You can also provide curved model lines, or it also accounts for openings, for example. You see that here, that situation, there are kind of situations which can be relatively complicated. I will do the same here for this load also. So, and now I have my subsystem with these loading patterns for the live loads. I just also want to remind you to another command, the filter loads command, which allows you to just filter through the loads within a view. You can also keep that view with that selection, for example, just recalling it again. And when recalling it again, you can display all again. So this is a very handy command, especially also nice when for the main system, of course. So, and now I configured my subsystem, and now I can start the analysis. The same dialog shows up with one extension. So for here, for example, you see that I now create boundary conditions at the supporting elements. So instead of exporting these downstanding members, these columns and walls as elements, we are creating boundary conditions based on the stiffness of these elements. Take some seconds to analyze all these load different pattern loads. And now we can have a look at the exported system through this visualization tool. And already you can see here that instead of having the columns in the model, now you see that supports. And also when switching to the loads, you can see that the effect of all these patterned loads. Yeah, going back to my to the presentation, to the PowerPoint presentation here. So regarding the next demo, I would like to show you a new feature for cross-section mapping, which allows you to use any kind of cross-sectional geometry in the analysis. So there is a new polygonal cross-section dialog which you can use to configure the properties of such sections. I will again switch back to Revit and close that model and open an empty model from here. All right, so this is an empty model. There are just some grid lines generated, and I now create a beam member. In this case, a rectangular concrete beam cast in place 30 by 16 centimeters. So this is a predefined family which is present in the families being provided by Revit, for example. And when switching to a 3D analysis view, you already see that beam with the structure model also. And as already said, when exporting the system the first time, or when clicking on this section mapping tab, the SOFiSTiK software analyzes the geometry of this member, of this Revit element, and tries to map an appropriate SOFiSTiK section for analysis. So, and you can here further modify this SOFiSTiK section, and you can already see that this section, of course, for analysis, you need more information than information which is just available in the Revit family. So, for example, information about reinforcement layers. So in this case, for this beam, we provide by default a lower and an upper reinforcement layer, and optionally also layers on the side flanges. And here you can further configure that section. You can also use a different section with different size. And after configuring, this information will be assigned to the Revit element and stored within the Revit database. And once you do the analysis now, this Revit, this SOFiSTiK cross-section is used for this Revit element. I will delete that element now again, switch back to the base view, and add a custom family. In this case, I will add a custom family which I prepared for myself, a custom family of a trapezoidal beam. So not much difference here, so relatively simple, but the process I will show you right now also works for more complicated sections. So in this case, as said, so this is a trapezoidal beam, a custom family, which you created by yourself. And now when clicking on the sections mapping command, you see that we now didn't assign any standard section. It could be possible, of course, so you could also assign the standard section here. But in this case, we created a so-called polygonal or free sectional layout. So it's not a standard section anymore. And now with this new dialog, which comes with version 2021, you can further configure this section. So you will see that I can just modify the already given rebar. So by default, we are just creating 2 layers of rebar at the upper and lower side. But you could also delete that rebar and reconfigure it again. And here you can configure it. For example, you can change the distance to the boundaries, or the number of bars being used, or the diameter, and other properties as well. I will now add another layer of reinforcement, another bottom layer of reinforcement with a distance of 50 millimeters to the first layer, and configure it again. So 3 bars again of size 20 millimeters. And assign it to a layer number 1. So there are layer numbers assigned, which you can then control later in the design process, for example. So each reinforcement layer has a number in SOFiSTiK. Okay, I could also further modify the geometry. There are different selection modes. So for example, I could also further modify this geometry using the script points. There is also the possibility to add, for example, additional auxiliary lines here. Just don't want to show it right now. And finally, I add another layer of line reinforcement at the sides, for example, to account for torsional stiffness here. I reduce that to smaller bars, and I also deactivate the outer bars of this layer because there are already 2 bars present. Maybe assign them to a different layer number. Same for the other side. You see that grip points. And now you see I configured this section, manually configured the rebars in this section. You can also change number of properties. Here you will also see that I have now configured the section with 3 layers. And now I store this section and store the assignment of this section. And now when exporting the system to SOFiSTiK, I just like to mention that you can then see in the report browser that this section has already been generated and is now present in the SOFiSTiK database and can be used for further analysis within SOFiSTiK. All right, so I will now again hand over to my colleague who will present further new features. Thank you so far.
Thank you very much. So we are now starting the third demonstration of this webinar. And here I would like to focus on the part member design and especially slab design, which was completely reworked in version 2021. And for this, without too much talking, I would like to jump into Revit. So you see already here the well-known now building design with several subsystems, and I will focus for this demonstration on subsystem number 3. First thing I will do is to make a load transfer using design options. I just wanted to show it to you. I will not talk too much and explain too much about it because this is not the focus of this webinar, and this is also not really a new feature. But I thought it was important to show it to you so that you see how it's working normally. So generating the loads from subsystem here, level 4, which is directly above the active subsystem, activating them in the active Revit view using design options of Revit. And with this, I would have this load transfer also available for my analysis. Now, talking about new features, I would like to show you how to generate global load combination in Revit. This is a completely new dialog in Revit 2021, where you can select the loads, add them, and adjust the coefficients. You can also rename the load combination to be able to find them maybe easier in the reports afterwards. So I just made the ultimate limit state combination. I will now make a similar service combination with some standard load cases and adjust the coefficients to 1s to obtain a characteristic service load combinations. Here again, I will rename it. And this load dialog allows you to define all the properties for the load combination, which you will need further in SOFiSTiK, especially the type, not only ULS and SLS, but also characteristic or fundamental or frequent is important in SOFiSTiK. And of course, this dialog allows you further functionality like duplicate, edit, or delete load combination. These load combinations are now created and saved inside of Revit. This means if you know already the load combination dialog of Revit, they are also present there as a third-party generated load combination, are visible and are, let's say, equivalent to the one generated with this dialog. It's just from our point of view, more comfortable and more complete to do them with the SOFiSTiK dialog. Once I've generated my global load combination, I will analyze my subsystem. Just to show you, this drop-down menu is now reworked. It's a bit new. And I will activate the analysis of load combinations too. So like my colleague showed already previously, the subsystem is generated in the background, and I can see in the visualization now my subsystem with single load cases, but also the two combinations which I just defined previously. So I already took care of the load of the finite element analysis, and now I would like to go to the design. For this, I will make sure the design browser of SOFiSTiK is activated. This is this side panel here, which was for me behind the properties. I will start the slab design command and select the slab element which I want to design. And I have now this new dialog, which is completely reworked in version 2021 of Revit, with the different options separated into tabs. The first tab is general information, like the name and the range of output which you want to have for this design. And at the top of the dialog, you also have the preview of the tabs you selected. Very important, in the newest version and service pack of analysis and design, you have this tab combination, which is allowing you to go between automatic combination, which are calculated and generated automatically by the software SOFiSTiK, or the global load combination, which you just define into Revit. This is done, or this has been implemented for all design tasks inside of Revit and can be used for all design tasks inside of Revit. The further tabs on the left are dealing with the design itself, with first the ultimate limit state design with bending and shear. Here you have some options which are new, especially the definition of maximum bending reinforcement. This options to define the distance between the different layers and the surface of the concrete. Here, I don't know if everybody knows about it. If you click on the line, you can see in the preview which direction is meant in the different slab elements. You also have, this preview has been reworked, so you also have some dimension lines to orientate and see how big is your slide and how big are your, for example, spans. Now the punching, so staying in ultimate limit state design, punching check, this one is already known from previous version. You can select between the design itself and just the checking. What has been added is, again, here's the reinforcement ratio. And now we go into the serviceability limit state design with crack width design. Here, important, as soon as you talk about serviceability, you can select several of the combination type, because we divide between characteristic, frequent, and non-frequent combination type for serviceability. Here again, like in the previous tab, you can define what kind of analysis you want to do. Some additional options to define the allowed crack width, and the reinforcement settings. Here again, if you click on one line, you see in the preview the direction. And finally, the last tab, which is completely new, is the deflection one. This deflection is just giving an impression of a deflection check. I mean with that it's doing a linear elastic analysis of the deflection. We are not talking about any second order effect or cracked or nonlinear. This is really just a linear elastic enveloping of vertical deflection. In order to compensate that and to give you an estimate, you can define a linear factor to increase the deflection. And you can also generate a warnings result. I will show you what this means afterwards in the report. Once you divide all your options, you can calculate your design. So you can start the calculation of the design of your slabs. And obtain the corresponding slab design report really soon. It just takes a few seconds normally. And you can see that in the report, I probably have some errors because I have already the red symbol on this dialog. This report is also completely reworked with version 2021. As you can see, we worked already a lot on the organization of the report itself. So everything is grouped under the label slab design for my design group. And I have for each part of my design a specific capital or a specific, let's say, subcapital, with first general information about the system and the design, ultimate limit state result, serviceability results, and finally some graphics about the required reinforcement. I will go quite quickly about the content of the report itself, so the graphic, and also maybe quickly combinations, showing you that we have some information about the combination which was used in the design. In my case, I have some punching failure which has to be designed separately, as shown here in my report. I can see further on here in the overview which points are making failure. And if I go further, I can see and find these points further here in the overview, so to know where are the points which are making problems. Serviceability will show you also some result about the decisive elements which are making the serviceability check. You will have some graphical impression of which elements where the crack width has been decisive, here in red in the different layers, and also for the linear deflection. As I mentioned earlier, you see now the linear deflection which was extrapolated with the scale factor, and you can see here in orange the part which is exceeding the limit which were defined in the dialogue. So this is very good to maybe see where are the potential problematic areas and decide if you want to do advanced analysis about this lab design, further in SSD, for example. Of course, at the end of the report, you have the required reinforcement in the different layers and in the different direction. Here, for example, as ISO areas, also shear reinforcement, if necessary. And finally, you can have, or you can ask for having an overview of points making problems where you have design errors. Here, small marked in red, for example. So this was, let's say, a very quick and standard output for my report. What is also new in 2021 is that you can adjust the content of this report. For this, you have here in this dialog the definition of the result content for slab design. You can ask to have, for example, more information. Here, I just want, for example, to have more punching result or detailed punching result for all positions. And you can adjust the graphical settings. So how my graphic will look like in the report. Interesting is here, you can also say, I want to have display of cut line results in my report, if I have some. So I just activated this one. And to be able to see it, I will define now a cut line. This is also not completely new feature, but quite recent. So I will just show you how it works. You click on the cut line. You make sure that you're in the right level, and then you make the cut line result. And well, to have it updated in my report and in my SOFiSTiK database, of course, I have to do the analysis of the system again to add the cut line in my database, and afterwards directly to trigger the calculation of my design again to update the report according to the new content of it. Okay, just very briefly opening the new report and showing you now in punching. So I have, as I asked, detailed information of all punching points. And I also have, when I go further below in the required reinforcement, so the required reinforcement according to the new representation, and also the corresponding cut line result, which I asked for. and for which I defined a cut line. Okay, I will just go further in the video to make sure that we have time to see everything. And want to mention, of course, I just showed you, or I just showed you in the video right now, that you can do this with global load combination because this is quite new feature. But as my colleague mentioned, you can also do it with a load pattern display, and you could just switch the filtering and trigger the analysis and the design again, and maybe use here the automatic combination of SOFiSTiK to not have to define manually the global load combination with all the single load cases. So I have one report, and I would to show you now this new publish function. This is something we implemented for version 2021, which is allowing you to see all the reports which are linked to this Revit project, ranked by data source or ranked by topic. And you can select the different reports. For example, here I take all the reports which are dealing with subsystem level 3. I can see in which order I want to have them displayed. And by clicking on OK, I can open the report browser and have them one after the other, see, really nicely encapsulated into chapters. And this is really nice because you can export them as PDF format or as docx format. And if you go into docx, I will just go a bit faster in the video. What is nice is you get a docx, which is containing the information of all the PLBs or all the SOFiSTiK report which you previously selected. And you can see here that the docx is automatically generating headings. So you can have automatically a really nice overview of the content of your Word document. So this was already it for the first, the 3 demo of this webinar, the first for me, about member design and about slab design. I would like to go now to the next one, which is a really nice feature, which is new in version 2021 about result visualization. For this, I also have a video. I just have to activate it. I mean, we are talking about the same project, of course, and the new features I want to show, or I want to talk about, is this show result. It comes in 2 versions, show in the active view or show in a new view. I will show right now, or I will talk about show in the active view. You can see really early here, you have when you start it, you have a dialog which is showing you the command is loading data. So this show result is really a live reading of the content of the database and a display of this result in Revit. It appears here as a new option or a new structural property, which is called the Revit view, where you can define what kind of result you want to see, what kind of data source you want to read from, the load case. You also have some, let's say, template where you don't have to click all the options and you can already prepare and have them really quick available. And the first function I want to show you is we can display meshing. So you can see the finite element mesh of your SOFiSTiK system inside of Revit. Here it's for the main system. You can see you have also some meshing of the walls here. And very quick, you can switch to a subsystem and have almost automatically the display of subsystem meshing. So this is really nice and quite quickly loading or updating. I will just switch off structural loads to see better the further results. Well, you have standard results. Slab results, for example, displays a bending moment in different direction. You can decide if you want to see the legend. And because I defined a cut line earlier, and I can also display cut line result, which is really nice. You can also play on the scaling to see better how it looks like. And what is interesting for subsystem, you can also display support result. And we are talking not about only main system support, we're talking also about subsystem support. So you can see here the result forces on the top of my support element, which are represented by the beam, by the columns and the wall in different styles. So average, distributed, or even resultant for the complete member. And here you can see it for the linear load cases, but also for the combination, because I analyzed it, so it's in the CDB, so the information is here. And of course, I did my slab design, so I also have reinforcement results available. For example, for the complete required reinforcement, and I can see required reinforcement as the surface result. I can also see, of course, cut line result. Same principle, it's in the database, I can see it. And if I want to switch the color, for example, of my color map, I can go here and configure the result visualization. Here we are using Revit analysis display style. So we give already some functionalities to check quickly and change the colors, but you can, maybe it's smarter for you to go in the analysis display style dialog of Revit and also pre-configure some display style. For example, I have one here where I did some really rough scaling according to the different standard layers of reinforcement. So base reinforcement and supplementary layers. And I can apply it to my reinforcement result and see where I want to place my supplementary reinforcement, or where do I need extra reinforcement in my slab. And I think I will stop there with the demonstration. I think you already see quite a lot of this new result visualization feature. And I would like to give the screen back to Andreas for the last part of our webinar.
All right. Thank you, Noélie. So, yeah, finally, just switching back what we have seen today. Yeah, so we have seen now 4 demos, starting from modeling to results visualization. And finally, I just want to remind you to some final features, which is just switch through the slides. What is new about SOFiSTiK and Dynamo? So we also provide a Dynamo interface within for accessing structural properties and analysis results within Dynamo. So for those who are familiar with Dynamo, it's a scripting interface, and this allows you to manually configure or manually do some kind of programming, I would say. And our SOFiSTiK Dynamo interface provides access to loads and analysis results, and this gives you the opportunity to support a number of use cases, for example. So, for example, if you want to access and write support forces and write them to Excel in some custom layout. So something which is not provided by default could be done by you manually. So, for example, we already do have customers who control their load takedown using these transfer loads for all the subsystems through a manually written Dynamo script, and to include that information in the design documents, for example. It's also possible to access the amount of reinforcement required. So, for example, you could access all the reinforcement required for a specific slab or for all the slabs and write them to a parameter. So you can check out shortly after doing an analysis, you can sum up the forces and get a first idea of the required reinforcement. Or you can also access pre-stressing information, and it would also be possible to create custom design checks. So this Dynamo interface is already present with version 2020. What is new with version 2021 is that we install the Dynamo interface directly with Revit Analysis and Design. So once you install Revit Analysis and Design, you should also see when opening the Dynamo viewer, you should already see also that Dynamo interface in the Dynamo viewer. So there's no need to additionally install it in a second step. Yeah. What else is new in SOFiSTiK Analysis and Design? There's one thing I would like to remind you to, is something we haven't covered in this webinar. It is also possible to create pre-stress or to slap pre-stress tendons in Revit. So, for example, by drawing model lines and then by using these model lines to create tendon geometry in a slab. And then you can do analysis of a pre-stressed slab. And with Revit, with the latest version, we also provide a link to another software called PTBot, which allows to create drawings and design drawings of these pre-stressing tendons of a slab. There will be a webinar next week on Tuesday showing you that workflow. So if you're interested in pre-stressing of slabs within Revit, I strongly recommend you to check our website and to check out this webinar next week. Other than that, a complete list of all the new features of Revit version 2021 and as well as version 2020 can be accessed through our webpage. So in the documentation, or also within Revit, just click on the help button. There we will find a link to the online documentation, and there you will also find a list of all the new features. Yeah, what else? So I think we are finished right now. Just want to remind you that also on our webpage, you will find a number of user reports showing you already successfully conducted projects with Revit. So there are also some videos and further information about what customers already do with this interface. Yeah, yeah, you can see that here. Also, directly on the web page, you can request a free trial, which runs for 30 days. As said, you will also find that BIM user reports there. So really recommended to check that out. Yeah, I think we are at the end now. So if there are some questions, I would say just post them in the side panel of GoToMeeting. We will definitely answer your questions afterwards, after this meeting, and send them to all of you in the aftermath of this webinar. You will also be able, of course, to access the recording of this webinar with your registration. So if you missed something or here, you can just check out the recorded webinar again. So in behalf of my colleague Noélie and myself, I will say thank you and thank you for attention and attending this webinar. Thank you.
Thank you.
Magst du?